All right, now that we're getting the hang of how these logarithms work, kind of their structure, let's start evaluating some of the expressions. So here, part A, we have log base 5 of 125. What is the value of that? So let's think about it in exponent form. You have your base 5 raised to some unknown exponent. I'm just putting a little box for what is that exponent, equals 125. So if we think about it, 5 raised to what power is 125? And we know that that will be 5 to the third power equals 125. So that 3 is the exponent that we're looking for. So what that means is the value of our log base 5 of 125 equals 3. This would be our final answer that we have. What is the value of that logarithmic expression? Okay, next one, let's go ahead and put it into exponent form. Our base is 1/4, so 1/4 raised to some power is equal to 16. All right, so 1/4 raised to what power is 16? Now, if we're raising 1/4 to positive exponents, that means we're multiplying 1/4 times 1/4 times 1/4. We would get like 1/16. 1/4 squared is 1/16. 1/4 to the third would be 1/4 times 1/4 times 1/4, which is 1/64. So we can see that we're not getting fraction answers over here. So let's consider negatives. What if our exponent was negative? And in this case, if we take that 1/4 and we raise it to a -2 power, that's how we get that 16. So we can rewrite log of 1/4, or log base 1/4 of 16 has a value of -2. All right, so log base 3 of 0. Again, we're going to go exponent form. So our base is 3. Oh, I wanted to show you guys this. So often when we're working with logs and we have to evaluate it or find the value, we might just say, you know what, I'm going to set my log expression equal to x. Now it's pretty easy. Instead of having to put this like, oh, here's a box, here's what is this blank space, we can just use our variable now. 3 raised to the power of x equals 0. So I just took log form, I put it into exponent form. 3 to the x power equals 0. And then we think about, all right, well, 3 to what power is equal to 0? 3 to the first is 3. 3 to the 0 power is 1. So if I just think through exponents that we know, 3 to the first is 3. 3 to the 0 power is 1. What if we went negative? 3 to the -1 power is actually 1/3. There's not actually an exponent you can raise a 3 to get 0 back as an answer. So that means that this log expression is undefined. All right, last one, we have log base 2 of 2 to the 8th power. So again, I'm just going to set that equal to an unknown quantity x, so I can put it into exponent form pretty easily. I'm going to take my base of 2, raise it to the power of x. So again, start with your base, raise it to your exponent, set it equal to the result, so equals 2 to the 8th power. What we want to recognize here is we have 2 to the x equal to 2 to the 8th. When your bases are the same and we know that the two quantities are equal, because there's an equal sign in between, that means that your exponents must be the same. X must equal an 8, which would give us 2 to the 8th power equals 2 to the 8th power. So when we say that x equals 8, we're finding this value, which is the value of the log expression. So we know that log base 2 of 2 to the 8th power, I'm just rewriting this, is equal to what we just found in 8.